welcome back to my YouTube channel. I am Meghana Vaijay from Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Computer Science and Engineering, 4th Sem CSC branch. Now I am going to discussing about the subject is discrete mathematical structure. In this subject, the subtopic is mathematical induction. Let us see the topic. First, I would like to give the introduction to mathematical induction. Mathematical induction is a powerful proof technique is used in the mathematics. It is primarily employed to prove the statements about natural numbers. The method consists of two main steps, the base case and the inductive step. Proof by mathematical induction. Let S be a conjecture involving a positive integer n. S is true for all positive integers if the following conditions hold. S is true for n is equals to 1, and if S is true for n is equals to k, then S is true for n is equals to k plus 1. The principle of mathematical induction. The principle states that if statement holds for the base case, it holds for all natural numbers. It is a form of logical reasoning that establishes the validity of an infinite number of cases. This principle is crucial in many areas of mathematics, including number theory and combinatorics. The base case. The base case verifies the statement for the initial value, usually n is equals to 1. It serves as the foundation upon which the inductive step builds. Without a valid base case, the entire induction argument collapses. The inductive step. The inductive step assumes the statement is true for some arbitrary natural number n. This assumption is known as the inductive hypothesis. The goal is to prove that the statement also holds for the next number n plus 1. Example of mathematical induction. A classical example is proving that the sum of first n natural numbers equals n of n plus 1 divided by 2. Start by establishing the base case for n is equals to 1 which holds true. Then using the inductive hypothesis show that it holds for n plus 1, completing the proof by the induction assumption. Common uses of mathematical induction. Induction is used to prove formulas involving sequences and series. It is also applied in combinatorial arguments such as counting problems. Additionally, induction can be utilized to establish properties of algorithms and data structures. Variations of induction. There are several variations of induction, including strong induction and structural induction. Strong induction allows assumptions about all previous cases, not just the immediate predecessor. Structural induction is commonly used in computer science to prove properties of recursively defined structures. First type of variation. Let a P of n be a proposition involving positive integer n. If first one P of n is true for n is equals to 1 and n is equals to 2. And second one, if P of n is true for some positive integers k and k plus 1, then P of n is also true for n is equals to k plus 2. Then P of n is true for all positive integers. Limitations of mathematical induction. Induction is not applicable to all types of mathematical statements. It requires a clear ordering of the natural numbers, which may not exist in some contexts. Misapplication of induction can lead to incorrect conclusions, emphasizing the need for careful proofs. Tips for successful induction proofs. Clearly identify the base case and ensure it is correctly established. Formulate a clear inductive hypothesis before proceeding to the inductive step. Review the logic of each step to ensure no gaps exist in the argument. Like assuming the statement is true for some even m belongs to z greater than or equals to 0, that is sine of m into pi is equals to 0. Then using the periodicity of the sine function. 0 is equals to sine of m into pi is equals to sine of m pi plus 2 pi is equals to sine of m plus 2 pi as taken common. Hence the statement is true for all even n belongs to z is greater than or equal to 0. Next, assume it is a true for some odd m belongs to z is greater than or equals to 0. Then 0 is equals to sine into m pi is equals to sine of m pi plus 2 pi is equals to sine of m plus 2 pi as taken common. Hence it is true for all odd n belongs to z is equals to greater than or equals to 0. Therefore, it is true for all non-negative integers and hence for all n belongs to Z. Finally, conclusion. Mathematical induction is an essential tool in the mathematician's toolbox. Mastery of this technique enables the proof of countless mathematical statements. Understanding induction fosters deeper insight into the nature of mathematical reasoning. This presentation provides a concise overview of mathematical induction, its principles, applications, and nuances. Thank you for watching, guys.